Hello friends, this video on Potentiometer part 5 is brought to you by examfear.com. No more fear from exam. So let us now try to understand how does it work, how the working of the potentiometer. So let us look at the working of the potentiometer. Construction we already discussed, right? So here we can say that this point is A, this point is B. Right? So this AB represents the long wire. This A also acts as one of the terminals of the potentiometer, and this point, let me call this end as C. So this end C acts as another terminal or the end point of the galvanometer. So now let us suppose we have to find out the potential difference between 2 points of a circuit. Let us call these 2 points as A and B. So what do we do? A, this capital A, this is connected to the small a. C is connected to B. So that means how is connected? A is connected to A of the circuit and C is connected to B of that circuit. So what is the aim here? We have to find out the potential difference between A and B. Right? So let us see how do we do that. So here we take one assumption that all the connecting wires which are used here, they have got negligible resistance. So there is no resistance in these connecting wires. So what will be the potential at point A? So potential at point A, if we assume that this wire doesn't carry any resistance, then potential at A will be equal to potential at A. That means potential at this point will be equal to the potential at this point. Similarly, we can say that potential at B, that is this point, will be equal to potential at some point before B. Because if you see, B is here, but this point is connected to some point in between A and B. Right? So the potential at this point will be equal to the potential at some point between A and B. Right? Now let us suppose we start sliding this jockey. We start moving this jockey and we find a point where the deflection in the galvanometer is 0. That means there is no deflection in the galvanometer, because as we keep sliding the jockey, we are actually changing the resistances. So we are actually changing the flow of current. So we find out a point on this long wire where the deflection in galvanometer is 0. So let us say that we found out some point P. Let us suppose there is some point P. So let us suppose at point P, deflection in galvanometer is 0. So therefore, if the deflection in galvanometer is 0, that means no current is flowing through this. That means the potential at point B is equal to the potential at point P, right? Therefore, we can say that potential at B is equal to potential at P, right? Now let the length AB, that is the total length of this wire, be equal to capital L. And let us suppose that the length AP is equal to small l. So this length is small l and this entire length is capital L. And let us also assume that the potential difference which is set up by this driving circuit is V0. So potential difference set up by the driving circuit is equal to V0. So that means V0 is the potential difference. The driving circuit connects these two, A and B. So V0 is nothing but the potential difference between A and B, that is between the two ends of this wire, that is V0. Therefore, what would be the potential difference between A and P? So the potential difference between A and P. Now in the previous slide I was telling you, if we know the potential gradient along a wire, we can find out the potential difference between any 2 points. Now what will be the potential gradient along this wire? Potential gradient is potential difference divided by length. So if you look at the entire wire, what is the length of the entire wire? AB, that is capital L. Right? So what is the potential gradient? Gradient will be equal to the potential difference between point A and B, which is V naught, divided by the length between A and B, which is capital L. So the potential gradient of this wire is V naught by L. So now if we want to find out the potential difference between A and B, this will be equal to potential gradient into the length distance between A and P, that is equal to small l. So this will be equal to V naught divided by capital L into small l. Right? That is the potential difference between A and P. Now we know that potential difference between A is equal to the potential at A is equal to the potential at A, and the potential at P is equal to the potential at B. Therefore we can say that the potential difference between A and B is equal to V naught by capital L into small l. So this is what we wanted to find out. But here if you see, we do not know what is this V naught. That is, what is the potential difference which is set up by the driving circuit. So how do we determine V naught? So once we determine V naught, we can find out the potential difference. Right? So now our agenda is to determine V naught. So now we have to determine V naught. How can we calculate the value of V naught? So what we can do is that in the previous slide, in this circuit, what we can do is, instead of this circuit AB, if we use a standard cell of EMF E, let us suppose instead of putting this circuit, if we use a standard cell, that means a cell whose EMF value is known to us. As I said, every cell will have a specific EMF value of its own. So let us suppose if we take a cell of a known EMF E. So in that case, what will happen? In that case, so if we replace AB with a standard cell of EMF E, so in that case we can say that E will be equal to V naught L naught divided by L. How did I write that? Using this expression. Because the potential difference between A and B, that is this potential difference, is equal to V naught by capital L, that is the potential gradient, into the length L. Now, when I have put another cell instead of that, so what will be the EMF? That will be equal to V naught by L, which is again the potential gradient, into the length. So that length in that time, let us suppose that the length will be L naught. So from this we can say that from this V naught will be equal to E into capital L divided by L naught. Now if we put this value of V naught in the previous slide, that means here let me call this equation as 1. So we will put V naught is equal to E capital L divided by L naught in equation 1. So what do we get? We get V is equal to V, that is, what is V? The potential difference between A and B. Let me call this as V. So V will be equal to V naught L by L. So instead of V naught, we will write it as EL by L naught into L by L. So this L and L will get cancelled. So this will be equal to EL by L naught. Right? So the potential difference between the points A and B will be equal to EL divided by L naught. So this is how we can find out. So L we already know, that is the point where the deflection of the galvanometer came out to be 0. What is L naught? L naught is when we replaced that other circuit with a standard cell. So that time where the deflection of the galvanometer came at 0, that was L naught. Right? So using these values we can find out the potential difference between the points A and B. So did you notice the speciality in this circuit? In this circuit, the potentiometer did not snatch away any current from the external circuit. That is why it did not affect the potential difference between the points A and B. So it gave value with much more accuracy. Clear? Okay, so this is how the basic working of the potentiometer takes place. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.